Hybridization. Today topic is hybridization. Hybridization equal number of sigma bonds plus number of lone pairs. Number of sigma bonds plus number of lone pairs. If the total is becomes 2, then the hybridization is sp. Hybridization always started from s orbital. Okay, if the total is 3 is there, s, then p2. If total is 4, s, p3. Total 5 is there, sp3d. Then 6, sp3d2. Then total 7 is there, sp3d3. Okay, what is the total? Number of sigma bond plus number of lone pairs. Now geometry is important. Suppose total is 2 is there, that means sp hybridization, the geometry is linear. What is this? Shape, we can say shape or geometry, right? Now only two elements, two atoms are there, obviously two atoms are linked like this, so the shape is linear. This shape is linear. Okay, suppose total is 3 is there, 3 all sigma bonds. Condition is 3 all sigma bonds. All sigma bonds are there. Hybridization is sp2. Geometry is trigonal planar. Trigonal planar. Okay. Now case 1 here, note, out of 3, if one lone pair is there, out of 3, if one lone pair is there, just you keep one lone pair any one of the corner. Then you take the remaining geometry. What is the remaining geometry? Is there, suppose I am keeping the lone pair here. Okay. So I am keeping the lone pair here. In that case, what is the geometry? It is looks like this. So this is the geometry of bent structure. Bent structure. Okay. Now two lone pairs are there. Keep two lone pairs. The remaining structure is just only linear. But in case of hybridization, there is no change in the hybridization. Geometry is changing if lone pair is there. Right? Now, if total 4 all sigma bonds, then your geometry is tetrahedral. Your geometry is tetrahedral. Suppose here, if one lone pair is there, then the geometry is trigonal pyramidal. So just one place you keep the lone pair. The remaining is pyramidal shape. The pyramidal is trigonal pyramidal. Right? Suppose two lone pairs are there. If two lone pairs are there, keep the two lone pairs here. Then what is the remaining shape? Just bent structure. Okay. If two lone pairs are there, therefore bent structure. But geometry is bent structure. Hybridization is sp3. Hybridization, there is no change. Hybridization always depends on the number of lone pairs and sigma bonds. Total 4 means sp3. But geometry is changing. All sigma bonds are there, tetrahedral. If one lone pair is there, trigonal pyramidal. If two lone pairs are there, bent structure. Next, suppose total 5 may all sigma 1, suppose. Then hybridization obviously sp3d. If all sigma bonds are there, all sigma, then trigonal bipyramidal. pyramidal. You can see the structure. This is the structure. Suppose here one lone pair is there. Suppose one lone pair is there. So in that case, what is the structure here? So this is very important. So where you will keep the lone pair? So note point is note here lone pair keep on triangle. Keep on triangle corner pin. So here the lone pair you have to keep it on the triangle. Then the shape is it's like this. Just you rotate this structure, it is looks like this. So that is seesaw structure. Seesaw. Okay. Total 5 is there. If one lone pair is there, your structure is seesaw. Right? Suppose two lone pairs are there. Suppose two lone pairs. In that case, keep two lone pairs here on the triangle only. Then what is the shape? One is straight line is there. Here one line is there. You can see like this, up and down, and this line. So it is T shape. This is the T shape. Geometry is changing. What about hybridization? Hybridization is not changing. Hybridization is as it is. Right? Next, suppose total 6. If it is total 6 is there, your hybridization is sp3d2. Yes, total 6 sp3d2. If all sigma bonds are there, then this octahedral. It is called octahedral. The symbol is OH. You want to write it octahedral, the structure name. Okay. Now here again note point is if it is lone pair, if one lone pair is there, where you will keep the lone pair? Now you should not keep lone pair on the square. You have to keep the lone pair above the square or below the square. Okay, that is the note point. So I am keeping the lone pair here. Below the square. Then my shape is square pyramid. Square pyramid. Okay. Suppose lone pair, two lone pairs are there. Two lone pairs. I am writing here. Two lone pairs are there. Then keep above one and below one. So your geometry is just square. Okay. So therefore your geometry is square planar. Square planar. When it is coming square planar, the total becomes 6. Hybridization is sp3d2. If it has two lone pairs, then your geometry is square planar. Right? Suppose total 7 is there. Total 7. In that case, hybridization is sp3d3. Okay. Suppose here, what is the all sigma bonds are there? All sigma. Then what is the shape? See here 5 pentagonal bipyramidal. Pentagonal bipyramidal. Pentagonal bipyramidal. Suppose here one lone pair is there. If one lone pair is there, then just keep the lone pair here. So then your geometry is like this. Here straight line. Okay, here straight line. So here there is no geometry. It is looks like octahedral. Like in here, due to this lone pair, distorted octahedral. Distorted octahedral. Distorted octahedral. Okay, this much is enough. Now the question is main question: how to count this total 7, total 5? How? So I will take few examples. Now CCl4 is there. CCl4. So how many bonds are there? Total 4 sigma bonds are there. Total 4 sigma bonds. All 4 sigma. 4 sigma means, first of all, this total 4 means sp3 hybridization. sp3 hybridization, the geometry is like this. Okay, what is this? Tetrahedral geometry. Tetrahedral geometry. Suppose here NH3 is there. NH3. So in this NH3, 3 sigma, 1 lone pair. See, nitrogen has 1 lone pair. Nitrogen has total 5 electrons. So one shortcut method I will tell you how to write this. You take the central atom valence electrons. 1, 2, 3, 4, 5 valence electrons. 3 hydrogens are there. Each hydrogen required 1 electron. So 3 electrons bonded with 3 hydrogens. Now 2 electron left. 2 electron together, 1 lone pair. 2 electrons together, 1 lone pair. Now 3 sigma bond plus 1 lone pair. Total 4. 4 means sp3. In this sp3, you have to take tetrahedral geometry first, but that is not the answer. So in the tetrahedral, you keep it 1 lone pair here. Then how it looks like? It looks like trigonal pyramidal. Trigonal pyramidal. Okay. Next. Suppose H2O is there. Okay. The shortcut method is, say, take the central atom. Write the valence electron, total 6 electrons, 1, 2, 3, 4, 5, 6 electrons. Oxygen valence electrons. You can write 1s2, 2s2, 2p, 4. This is the valence shell, total 6 electrons. Here 2 hydrogens connected with 2 electrons, then remaining 2 lone pairs. So 2 sigma plus 2 lone pair. The total is 4. 4 means hybridization is sp3. Right? Now you have to take the structure is this tetrahedral structure. In this tetrahedral structure, you can keep 2 lone pairs. 2 lone pairs. So what is the remaining structure? Just bent structure. Bent structure. Hybridization is sp3. Okay, geometry is bent. Next, few more examples. Carbon dioxide is there. Carbon dioxide. Okay, carbon total valence electrons 4. It is connected with 2 oxygens. Each oxygen required 2 electrons. Total sigma bonds. Sigma bonds are 2. Lone pairs are 0. Total 2. That means sp hybridization. Sp means what? Linear. Okay, like this you can do any question. Suppose SOCl2. SOCl2. What is the central atom here? Sulfur is central atom. Now sulfur 1, 2, 3, 4, 5, 6 electrons. Now one oxygen is there. Oxygen required 2 electrons. Each chlorine required 1 electron. Remaining 2 electrons, 1 lone pair. See here, you should not count pi bonds, only sigma bonds. So sigma bonds equal total 3, lone pair equal 1, total 4 means sp3 hybridization. Okay, sp3 means again you have to take tetrahedral geometry. Again you have to keep 1 lone pair here. So what is the answer? Trigonal pyramidal. Trigonal pyramidal is your answer. You can take any example. Suppose xenon O2F2. Okay. So xenon electrons total 8. 1, 2, 3, 4, 5, 6, 7, 8 electrons. 2 oxygens are there. Each oxygen required 2 electrons. Next fluorine and fluorine. These 2 electrons. Always lone pair means 2 electrons. Now count it sigma bonds. Oxygen 1 sigma bond, another oxygen 1 sigma bond. 2 plus 2, total 4 sigma bonds plus 1 lone pair, total 5. So sp3d, your hybridization is sp3d. sp3d means generally the total 5 means trigonal bipyramidal you have to take the structure, but this is not the answer. So later you have to keep the lone pair. Note point is here, whenever triangle is there, lone pair you have to keep it on the triangle. So what is the remaining structure? Remaining structure is seesaw. Okay, like this you can write any given compound hybridization and structure. Suppose I am taking here xenon O4, xenon 1, 2, 3, 4, 5, 6, 7, 8. Each oxygen required 2 electrons, lone pair. Now sigma bonds, see 4 oxygens means 4 sigma bond, lone pair 0, total 4, no lone pairs, that's why tetrahedral, the short symbol is TD, tetrahedral. Okay, or any example you can take SCl2, SCl2. Now sulfur 1, 2, 3, 4, 5, 6, 7, sorry, only 6 electrons, valence electrons. Now 2 chlorines, remaining 2 lone pairs. So 2 sigma plus 2 lone pair, total 4. 4 means sp3 hybridization. Geometry, the 2 lone pairs, so bent, bent, bent. Okay, you can see here bent structure, right? So like this you can write. Suppose cations and anions are there. So CH3 plus is there. CH3 plus. Now take 1, 2, 3, 4 electrons. 1 plus means there is no electron here. 1 electron less. Only 3 electrons are there. 1 hydrogen, 2 hydrogen, third hydrogen. Total how many sigma bonds? Total 3. So your hybridization is sp2. sp2. What about geometry? Whenever 3 all sigma bonds are there, take 3. Trigonal planar. Trigonal planar. Okay. Next. Suppose minus. Suppose CH3 minus is there. CH3 minus. Now take carbon valence electrons. 4 electrons. 1 extra electron is there. Minus means you have to take extra electron. Now total 5 electrons, 3 hydrogens, here 2 electrons, Milker 1 lone pair. Total 3 sigma, 1 lone pair, total 4. That means sp3 hybridization. sp3 means tetrahedral geometry. Like in here 1 lone pair is there. So the answer is trigonal pyramidal. Okay, like this you can do cations, anions, whatever given, you can do this. Now last one more example I will explain you. PCl5. Okay, phosphorus 1, 2, 3, 4, 5. All sigma bonds. Total 5. 5 means sp3d. Trigonal bipyramidal. Trigonal bipyramidal. Now suppose H2SO4 is asking sulfur. Now take the sulfur. How many valence electrons are there? If you know the structure OH, OH, here directly 4 sigma bonds are there. So 4 sigma bond means sp3 hybridization, tetrahedral geometry. Okay, you can do like this easily.